Hi, today we're going to be solving rational equations. And number 2 is a rational equation. Number 1 is actually a linear equation. But we're going to start with that, and I'm going to show you on this really simple problem how 3 algebraic ways that you can solve this. Now, you were taught these particular type of questions in Algebra 1, so we'll see how much you can remember. Okay, so one way that we could get the solve for problem 1 is that we could just combine these two fractions together into a single fraction and see what happens. So I'm going to rewrite the problem. Okay, so if we were to combine these two together into a single fraction, well, we learned already that when you add fractions, you need to have a common denominator. So the common denominator between a 2 and a 3 is 6. And that means if I have to multiply a 3 to a 2 to make a 6, I multiply a 3 to the x to get 3x. And similarly, if I have to multiply a 2 to a 3 to make a 6, I multiply a 2 to the numerator. Now, since those have like denominators, I can go ahead and add the two fractions together. And now we have a proportion. So if I put this over 1, we can cross multiply and divide to get our answer. Another way to do this problem, and I'll start by rewriting it, is that we can make the denominators all the way across be the same denominator. So include the 10 in all this, and a 2, a 3, and a 1 all share a common denominator of 6. And you're going to see similar steps coming out if you compare it to method 1. So again, we're going to multiply each of these by 3 to get a denominator of 6. All right, the second fraction we multiply by 2 to get a 6 denominator. Oh, I apologize. That should have been 3x. And the last denominator, I need to multiply a 1 with a 6 to make it a 6. So similarly, do that to the numerator. If you do it this method, well, when you add fractions, you add the numerators together and you keep the denominator. So since we have a common denominator, we simply erase the denominator. And notice that we're left with 3x plus 2x equals 60, which then is 5x equals 60, which is now the same thing as over there, and x is 12. And lastly, the third way that you can do the same problem is to recall that you can do whatever you want to an equation besides dividing out a variable. You can add anything you want to both sides, multiply anything you want to both sides, and you would create an equivalent equation. So on this particular problem, I really don't like these fractions. So what I want to do is I want to get rid of these awful denominators. And so I need to think of something that's going to multiply throughout the entire equation to get rid of all 3 fractions. Well, the 1. So if I look at 2, 3, and 1, what's going to get rid of it is if I multiply by the LCD. And this is our third algebraic method. So if I multiply everything by 6 to all the terms, what happens is I'm going to reduce before I multiply. So this 2 goes into that 6 3 times, and I have 3 times x, which is 3x. 3 goes into this 6 2 times, and 2 times x is 2x. And 1 was just a placeholder. 6 times 10 is 60. And now notice it's the same again as this step. So all 3 methods will get you to the same step. It's just how you get there. All right, so I out of all of these methods, I prefer number 3 because I would rather get the equation as simplest form as possible, although quite a few students will like number 2. Number 1 is actually going to be the hardest today because some of the denominators we're going to get into are going to be kind of complex, and to do the cross multiplying method will actually be more troublesome. All right, so number 2 now, I'm just going to do it by my method 3. So, or I'll do it actually by method 2 and method 3. Again, just to have you guys see the difference. So I'll write it. Okay, so in method 2, my goal is to create a common denominator throughout all the fractions, all the way throughout. So what would be the LCD of an x and a 5x and a 1? All right, and the LCD between those would be a 5x. Okay, so that means that I have to multiply a 5 to that x. So I multiply a 5 to the 2 to make 10. For this one, this denominator was the same, so 3 stays. And for 1, I have to multiply that with a 5x, so I multiply the numerator with a 5x. So if I do it this way, then my denominators all go away. Because I'm strictly solving, the denominators are all the same. That means the numerators are the things I need to focus on. So I have 10 plus 3 equals 5x. And that gives me to 13 equals 5x. And if I divide by 5, you can either say it's 13/5, or you can divide that and it will become 2.6. So whichever answer you prefer. All right, so now doing it by method 3. This is where I actually want to eliminate those denominators first. So instead of getting them all the same and then eliminating them, we're eliminating them in the beginning. Again, after this, I'll teach it to you one more time. You can choose whichever method you prefer. So the LCD is 5x. So we're going to multiply each fraction by 5x, or each term. And then we're going to reduce before we multiply. So x and x reduce, and then you have a 5 times 2, which is 10 left. 5x and 5x cancel. And this was just a placeholder. And again, notice it's the same line. All right, so 13 equals 5x. And then again, x is 13 over 5, or 2.6. Okay, so that was stuff that you've already done. All right, so the only thing different this year is that the LCDs are going to be a little bit more complex. Again, I'm going to just focus on the 2 last methods I really like. The cross-multiplying method I think is a little bit harder. And then I want to, again, bring in the graphic version of how to solve, because that's always important to have something to fall back on. So number 1, algebraically, we can either create LCD, then drop it. That's one method. And then the other method is to multiply LCD out first. Okay, so again, after this, you can decide which method you prefer. All right, so problem number 1. The denominators, all the terms all the way across, x and x plus 1. All right, we want to create an LCD for all of them. Okay, the LCD, x plus 1 and x, I cannot multiply anything to one to make the other, so I need to put them both together to form the LCD. Okay, in the first fraction, I needed to multiply an x plus 1 to that denominator, so I also multiply an x plus 1 to the numerator. You can either distribute this now or write it as it is. I'm going to distribute it now and get 2x plus 2. The second denominator, I need to multiply this group with an x. So I have to multiply the numerator with an x, and I get 6x. And the last denominator, I need to multiply both items. So that means I need to multiply the 3 with an x and an x plus 1. So for this one, I think I'm going to leave that the way it is for now. All right, so I'm going to now, since all the denominators are the same, I'm going to wipe out the denominators and just keep the numerators. Okay, so now I'm going to deal with this ugly guy. This 3x, a lot of students think they have to distribute the 3 to the x and the x plus 1, but since that x is a single x on the outside, you're going to treat 3x as one term together, and 3x needs to be distributed to both terms. So you get 3x squared plus 3x. Okay, now we have a power 2 in the equation, which means that you should understand we're going to combine like terms and then bring everything over to equal 0. So first off, those two are like terms. They make 8x. All right, power 2 equation. I want to bring everything over so it equals 0. All right, so now we get 3x squared minus 5x minus 2 equals 0. All right, now you have to factor. And if I factor this, I'm not going to go through the AC method, but you could in the future. And then set both equal to 0. I ran out of room, so I'm just shortcutting this a little. All right, x is 2 and x is negative 1/3. Now, the only thing you have to make sure is that neither answer will create a 0 denominator in the original problem. If you recall, that means it's undefined. Negative 1/3 would work in both denominators, and 2 would work in both denominators, not creating a 0 denominator. So both answers are acceptable. All right, so now we're going to do it the other method, and this is the last time I'll do it both methods. We are going to, first off, instead of creating a common denominator, we're going to multiply the LCD out. And so we already discussed that the LCD is x times x plus 1. So for this this algebraic approach, we're going to multiply x and x plus 1 all throughout each term. Okay, and what happens is you're going to cancel before you multiply. So that 2 or that x goes into that x, and you're left with a 2 and an x plus 1. This x plus 1 cancels that x plus 1, and you're left with a 6x. And then similarly, the other side, we can't cross off anything. We leave it. And again, this is going to end up being the same equation that we had in method 1. Okay, combine like terms. And then at this point, you would do exactly what you did over here. So I'll stop. You're going to get the same work at that point. So it's just the beginning step, how you want to get to this equation right here. That's going to make the difference of what you choose. And again, I want to stress that you can solve equations always graphically in your table or on the graph if you put the left side of the equation in graph 1 and the right side of the equation in graph 2. I will warn you though, when you have x's in the denominator of a fraction, you will sometimes get really ugly graphs that may be difficult to read. So this isn't always going to be the best option, but at least it's an option you can try to use. Okay. So if I press graph, not too bad. So if you can see, I do have 2 hits right there. And on the graph, I can do second. Oh, first off, let me get the graph over here. You would just sketch that graph on your paper. And then to get the points of intersection, you would use your intersection option on whatever particular calculator you're using. And there we have it. We have negative 0.3 repeat bar, comma 3. And then the other intersection will end up being at 2, 3, but we can do it. And your x values are your answers. Please make sure you put a 0.3 with a repeat bar on it. If you know that that's 1/3, that's even better to write it as negative 1/3. And don't forget, you can always go to your table as well. The only problem is here's our 1 match, 3 matches. There's our answer of 2. But the other answer is a fraction, so unless you knew to change your table to go by thirds, you would not find it. That's the only issue with the table. All right, so we'll try a few more examples. Okay, so I think I'm going to stick with creating common denominators. I think a lot of you guys might prefer that method more, even though I actually like to multiply the LCD out. I think many of you guys would actually prefer to make a common denominator first, and then instead of multiplying the LCD like I like. So, okay, problem number 2. We're only going to do it by one method. We want to create a common denominator. So for this one, we definitely need to factor out the last guy. Okay, and your common denominator is going to be x plus 3 times x minus 1. That'll cover all the fractions. So the first fraction, we have to multiply x plus 3 with an x minus 3. And I'm just going to leave it like that right now. You could distribute that out right now, but maybe we'll do one step at a time. The second fraction, we have to multiply x minus 3 with x plus 3. Again, I could distribute that, but I'm going to just leave it. And then lastly, the last fraction, we don't have to multiply by anything, so that's always nice. The 8 will stay. So for this method, you create a common denominator, and then you get rid of it. And then the leftovers are what we have to deal with. So at this point, I am now going to distribute, and that's going to give me 2x squared. That's going to give me negative 6x. This plus sign goes with the 3, so you're distributing a positive 3. And then distributing a 3 again. And now it's beginning to look a lot nicer. Combining like terms. You have a quadratic equation, so you have to think equals 0. So subtract over the 8. right, and then now we have to factor. So if I factor that again, you could do the AC method. I am just going to give you the factoring. Oops, I apologize. 9 minus 8 is positive 1. Okay, so if I factor this, it's going to give me those factors. And then setting each equal to 0 and solving, I get 1/2 and 1. And again, the only thing I have to do is make sure that my answers are viable. As long as they don't create a 0 denominator, I'm fine. 1 would work in all the denominators, and 1/2 would also work in all the denominators. The only bad answers would have been if I had gotten an answer of 3 or -3. Those would have been rejects. But 1/2 and 1 are perfectly fine. And I can always check to see for myself that they work, but they do work. Okay, so moving on, example 3. I'm going to again stick with this method. I think more of you guys would prefer this method. So we're going to create a common denominator. And this last denominator you're probably going to want to factor in order to see what the least common denominator would be. So if I factor that, you'll get x minus 5 times x plus 2. Which, if you notice, is the other two denominators. So that is going to be the LCD again. Okay, so creating a common denominator all the way across and filling in the numerators, we have to multiply the first fraction by x plus 2. All right, the second fraction, we have to multiply that with x minus 5. And the last fraction, denominator stays the same, so the numerator stays the same. Crossing off the denominators at this point, we have x being multiplied with x plus 2. Now this is really important. That negative goes with that 4. So that means you're really distributing a -4 throughout. And that's a very problematic spot for a lot of students. So be careful when there's a minus sign. So that's going to end up being -4x plus 20 equals 28. Okay, and then the rest, we have a power 2 equation, a quadratic. So we're going to think simplify and equaling it to 0. All right, factoring it. Okay, and then I just have to see if my answers are viable. 4, if I plug in a 4 in all the denominators, I do not get a value of 0. So this is good. -2, though, I have a problem. If I plug in -2 into this denominator, I will get a value of 0, which means that there is a problem with that answer. That is going to be a reject because it causes a 0 denominator in the original problem. So therefore, we only have one answer, and it's 4. All right, and I'll do one last problem with you. Example 3. Notice that the directions say solve the following for x in simplest a plus bi form. Again, please learn to read the problems. This is going to imply a negative number under radical. So therefore, that also means that this guy, when we end up getting an equation that's we have to solve is not going to be factorable. So that tells me a lot. It's very powerful what that's saying. So again, since we have an x in the denominator, we're going to make all of these have a 1 denominator and then create an LCD out of all the fractions. And this is not too bad. The LCD of an x, a 1, and a 1 is an x. So the first fraction numerator is going to stay. The second fraction we need to multiply by x. Well, x times x is x squared. And the last denominator we have to also multiply by x. So since I have all the denominators the same, I'm going to wipe out the denominator. All right, I have a power 2 equation right here. So I want to think equals 0. So I'm going to subtract the 2x over. And also, I'm going to rearrange. We always want the x squared term first, the single x term second, and then the non-x term last. So all I did was shuffle the pieces around. And now we're going to, well, we don't even bother trying to factor. Because it says an I know it's not factorable. So you have a couple options. You've learned other techniques of how to solve a quadratic. We, at this point, could do completing the square method, or we could do the quadratic formula. So, you know what? I actually think the completing the square method will work a lot nicer because that middle term is a 2. So I'm going to do it by that way. But feel free if you'd rather do it by the quadratic formula. That will also be a viable option. So if you recall, completing the square method, I need to kick over the 3. So I'm going to subtract the 3 over. And then I need to figure out what number to add here and also add to the other side. So if I split that middle term, the x term, in half and square it, I get, I get 1. So I'm going to add a 1 to both sides. And then you're going to factor this side, which is going to be x minus 1 squared equals -2. Square root both sides to get rid of the power 2. And that simplifies to I radical 2. And then lastly, add the 1 over. All right, but feel free to have use the quadratic formula, like I said. Okay, at this point, you can work on problems, on the practice problems if you want, numbers 3 and 5. And I will just put up the work and you can just verify that you were right. All right, actually just do problem 3. And if you just do problem 3 and check your work, hopefully you can compare it to mine. And if you'd made a mistake, hopefully you can follow the steps to see where you got it wrong.